Okay, so the last video in this chapter 3, we will be making a graph that consists of 4 graphs like this. We'll also make something like this, a little bit different than that. And something like this, where now this one is not as high, I believe, as these. And sorry, that's this one. This one is not as high as these. And even combining this graph with these two on one screen. And similarly here, combining objects on one screen, different objects on one screen. So we can use the par function that we've been using like this here. So this MF row gives you a matrix with n rows and n columns. So in this picture we have 2 rows and 2 columns, so we would use 2 by 2, which you can see here, 2 by 2. So you set that parameter, and then you begin plotting. And you do a plot, you do a histogram. We didn't study this, but this is just another high-level function called histogram. And we do a box plot. We didn't study that. That's just another high-level graph called a box plot. So when we do all of these, we get these 2 dots first, and then this and this. Now notice in that example that they were filled in by row, which is a little different than we said happens with matrices in general, but they were filled in row. Like this came first, and that was in the first place, and then this was to the right of it, right? Plot again, right? It wasn't this way. This one is not down here. Okay, if you wanted to do it so that that was by column, you could use this instead of this. Okay, but they don't do that. They just do by row here. He makes a short note here. He says, for the histogram function, it has a default title, actually. So if you don't want that default title, you could do this, or you can do this, or you can fill it in with another title, which is what he did here, I think. Sorry. What he did, histogram here, he filled it in there. Right? Instead of using the par function, you can also use the layout function. And that takes as its input a matrix object. So here we have a matrix object, and it has, strangely enough, 1, 1, 2, 2 as the elements, but it's a 2 by 2 matrix. So this says that the first object, note that by row is true, so it's not going to be filling in by column. It's set to, by row is set to true. So these refer to the objects that we're going to be plotting. So this says that the first object is in the space here and here. In other words, it's in the first row. The next object that we're plotting is in the bottom left, and this is in the bottom right. So we get, let's do it. We get that. So the first one spans the first 2 spaces here, and then this goes there. So here's it. Here again is it. So it's by row, so we're doing it across and then this way. And we're saying the first object, which is a histogram of weight, goes in this position and here, so that means that it spans both of them. And then here and here. Now you might ask, well, what would happen if we didn't use by row equals true? That would mean it would go down, down. So the first one would cover the first 2, the whole first column, and then this would be the first row of the second column, and the second row of the second, what do I want to say? The second row, second column. Okay? So it would look like this. Okay. So again, this was not using the par function, this was using the layout function. Okay, let's do one more. So suppose we want this figure, this layout. So what's happening here is that this is these two figures are 2/3 of the what should I say? 2/3 of the height of the whole thing, and this is 1/3 of the height of the whole thing. And this way, this is 3/4 of the width, and this is 1/4 of the width. Okay, so that's the way it looks. Now, how do we get it to look that way? So we can use, so this part is exactly the same as before, up to here, but we're throwing in this, and this, and this. So the widths are, the total width is 4, and the first part is 3, and the second part is 1. So it's so this is 3/4 of the whole width, and this is 1/4 of the whole width. So that's how we divide the. That's how we space the widths of the row of the columns. The widths of the columns. So that's why it looks like the width of. Now this one, it doesn't apply to this one, but this one it applies to. The width of the column. This is 3/4, and this is 1/4. So it's 3 parts out of 4 and 1 part out of 4. Okay, now the height, the widths of the heights, that's kind of, but anyway, the widths of the heights are 1 and 2. So that means this is 1 part out of 3, and this is 2 parts out of 3. So this is 2/3 of the height. So that means the bottom row is 2/3 of the total height, and this row is 1/3 of the total height. Now, this still, the first graph still spans this and this. So in other words, it's still in the, and we're still doing by row is true, so it still spans the first two positions, meaning by row, so it's the first place and the second place. Whoops. That's not right. But anyway, you can see it. First place and the second place here. Okay. So the explanation is about this function, and I'm sorry, this parameter and this parameter that we just used. Optionally, you can include these options in the layout function to control the size of each figure more precisely. These options have the form. So this one is a vector. So it was, what was it for the width? It was, I think, 3 and 1 was the vector. So vector of values for the widths of the columns. So the first column was 3, and the second column was 1. That's the percentage. And heights, a vector of values for the heights. Relative widths are specified with numeric values. So that's what we did, 3 and 1. If you wanted if you wanted to specify instead of relative widths, like 3 and 1, meaning 3/4 and 1/4, you can do absolute widths in centimeters with this function inside, well, with that function. Okay, and the last part is creating a figure arrangement with fine control. So how can we lay one on top of the other? So here we're laying actually 3 together. So how do we do this kind of thing? So he says there are times when you want to arrange or superimpose several figures to create a meaningful plot. Doing so requires fine control over the placement of the figures. You can accomplish this with the fig graphical parameter. In the following listing, 2 box plots are added to a scatter plot to create a single enhanced graph. Okay, so let's look at it. So for those of you who, well, you should hopefully know what a a box plot is. This is supposed to show that in the x direction, this direction, the median of the x points, or the median of the x coordinates, is here. That's what this line is for. And this is called the lower quartile and the upper quartile. Anyway, and here's another one for the y. So it's supposed to give us some extra information besides just the scatter plot. So to figure out how this is done, we think of the whole graph as spanning from 0 to 1 this way and up to 1 this way. So it's the whole unit square. In other words, it's like this. By the way, it's like this from 0 to 0 to 1 0 to 1 1 and so on. So this is the whole space. So the whole graph occupies that space. So then, then we use this fig parameter, which takes a vector, and these two determine the horizontal span, and these two determine the vertical span. So, for example, here for this one, for this scatter plot, we want to go from 0 horizontally to this far. We don't want to go all the way this far. So this is 0.8 of the whole thing. And then from here up, this is also 0.8. So we'll use that figure, and we'll use from 0 to 0.8. Sorry, from 0 to 0.8, from 0 to 0.8. Okay, so we make that, and then we do the plot. And then we do another par. So this will apply to the next plot, which is the box plot here. So we'll do that. And so the next figure expands the same horizontal distance as this one did, but it starts at 0.55 and goes to 1. And this is for the next box plot. Now, it doesn't look like it starts at 0.55, but it definitely doesn't look like it starts at 0.55. But I guess there's more stuff around this than we can see, so it actually expands down here. So it's a little bit odd. And then for the next one, it supposedly goes from 0.65 to 1 along the x-axis, but it doesn't look like it. That means from 65% of the x distance to 100% of the x distance. It certainly doesn't look like that. It's just a little bit here. But maybe it actually expands out into here. So I don't know. We'd have to play around with these numbers and see how they change, and because maybe this is just the way he wants it to look. Okay. And then, so that's the way they work. And when you're adding a figure to an existing graph, you have to use this option. So you can see that we started out here. We didn't need to use it for the first one because there was no existing graph. But now we are making another graph, the first box plot, but we want it to go on the same one as here. So we use new equals true. It means new on the same, I guess a new graph on the same space. And then we have to do that again here, new equals true. Otherwise you'd get just a new graph. So he says you have to experiment to get the placement right. So whether it's this or whatever it is, you have to experiment with it to make it look the way you want. Then he says, as a caution, the amount of space needed for individual subplots can be device dependent. So if you're using Windows, it might be one thing. If you're using, I don't know, maybe even it might be dependent on the monitor, but I don't think so. So anyway, if you get an error in plot.new, figure margins too large, if you get this error, he says try varying the area given for each portion of the overall graph. So try and play around with it. So he says you can use fig graphical parameter to combine several plots into any arrangement within a single graph. With a little practice, this approach gives you a great deal of flexibility when creating complex visual presentations. Okay, so we're finished the graphing chapter 3. Let's just read with a summary. In this chapter we reviewed methods for creating graphs and saving them in a variety of formats. The majority of the chapter was concerned with modifying the default graphs produced by R in order to arrive at more useful or attractive plots. You learned how to modify a graph's axes, fonts, symbols, lines, colors, as well as how to add titles, subtitles, labels, plotted text, legends, and reference lines. You saw how to specify the size of the graph and margins, and how to combine multiple graphs into a single useful image. Our focus in this chapter was on general techniques that you can apply to all graphs. Later chapters look at specific types of graphs. For example, Chapter 7 covers methods for graphing a single variable. So most of the graphs we did in this chapter were not single variable, but the box plots are single variable graphs. But anyway, graphing relationships between variables, that's when you have more than one variable, will be described in Chapter 11. In Chapter 16 we discussed advanced graphic methods including lattice graphs and interactive graphs. Interactive graphs let you use the mouse to dynamically explore the plotted relationship. That sounds pretty cool. In other chapters we'll discuss methods of visualizing data that are particularly useful for statistical approaches under consideration. Graphs are a central part of modern data analysis, and I'll endeavor to incorporate them into each of the statistical approaches we discuss. Well, we're going to switch out of this book soon, fairly soon, but we'll also be using graphs a lot. In the previous chapter we discussed a range of methods for inputting or importing data into R. Unfortunately, in the real world, your data is rarely usable in the format in which you first get it, so it's usually messy. In the next chapter we look at ways to transform and massage our data into a state that's more useful and conducive to analysis. Okay, so that's the end of Chapter 3.